Hello, Math 2 students. I wanted to give you another opportunity to copy down the notes about the key characteristics of quadratic functions and the parabolas that they make when you graph them. So if you haven't copied down these notes, please pause the video right now, take a screenshot, copy it down on a piece of paper, take a picture with your phone, find some way so that you have these to look at as you're answering problems on your homework and watching the rest of this video. On this problem, we have the function d of t equals negative 16t squared, and they tell us that represents the distance in feet a dropped object falls in t seconds. A rock is dropped from a height of 64 feet. After how many seconds does the rock hit the ground? And some people might think, well, it depends on how heavy the rock is, but that is not the case. You should remember from science that even though things have different masses, as long as there's not too much air resistance, they all will fall at the same rate. So if you drop two different objects, two rocks, one that's heavier than the other, both from 64 feet, they'll both hit the ground at the same time. So what do we know about this problem? Well, first, we know our A value is negative 16, and that tells us some things about our parabola. It tells us that our parabola will open down, and it tells us that our parabola will be a vertical stretch compared to the parent function. Now the y-intercept. They're telling us the y-intercept in the problem because they're telling us how high the rock was when time was 0, before it was dropped. And so if you look at the graph, I'm going to put a point right here, and I'm going to say that that point is 0, 64. So when time was at 0, the rock was at 64 feet. So what that tells us, that is our y-intercept. So our y-intercept is 64, and that means our c value is 64. Now, where's our vertex? In order to understand this, it might be helpful to think about what this graph is representing. It's representing the distance that the rock falls as time is passing. So some students think that this graph is a movie of the rock falling, and they think that the graph should look like this. But that would mean the rock fell to the ground with no time passing on the x-axis. So the reality of a falling object is that it gets faster and faster and faster the closer it gets to the ground. So it will be moving the slowest at the top, and then the line will turn into a more straight down line as we go. So what shape will that make? It's going to make a parabola. So our parabola is going to look like this, although the part on the left side of the y-axis isn't really there because that's when time is negative. So our parabola would look like that. That is a graph of a falling object. The object is getting closer and closer and closer to the ground, but while that's happening, time is passing on the x-axis. 1 second goes by, 2 seconds go by. But by looking at this picture, we can see our vertex is at 0, 64. Now, our axis of symmetry is going to match the x-coordinate of the vertex. So our axis of symmetry is x equals 0. For our domain and range, we're going to come back to that at the end of the problem. For now, what we need to concern ourselves with is this point on the graph. That point on the graph is the amount of time that has passed for the rock to get to a height of 0. The amount of time that has passed in order for the rock to get to a height of 0. So what does that mean about our problem? How are we going to find that time? How are we going to solve for t? Well, we're going to start with this equation. We know that d of t is equal to negative 16t squared because our a was negative 16. But also by looking at our graph, we know that our y-intercept is 64. So our c value is going to be 64. So we have this equation right here. And we want to know the time when the height is 0. So we want to know if the distance is 0, what's the time going to be? So that equation is going to look like this. 0 equals negative 16t squared plus 64. And in order to solve this equation and find out what t is, we're going to have to start by taking out the greatest common factor. So we'll have 0 equals negative 16, which is the greatest common factor, multiplied by t squared minus 4, because negative 16 times negative 4 is positive 64. Now our binomial that's in the parentheses is a difference of two squares. T squared is a perfect square, and so is 4. Now we're going to have a sum and difference pattern. So we'll have 0 equals negative 16 times t plus 2 times t minus 2. So now we do the zero product property. We find out t equals negative 2, which doesn't make any sense at all because you can't have negative time. But that's this point over here on the graph. This would be at t equals negative 2. That's why we're not paying attention to the left-hand side of the graph. But the zero product property on the second set of parentheses will give us t equals positive 2. And that's the answer to our question. How much time will go off the clock while the rock falls 64 feet? Well, it's going to be 2 seconds. So this would be 1 second. This would be 2 seconds. And so the answer to the question, after how many seconds does the rock hit the ground? The rock hits the ground after 2 seconds. Now, what does this mean about the domain and the range? Remember, the domain is every possible x value that shows up on our graph. Well, we're only talking about these x values on this part of the parabola right here. So our x values are times. That's only going to happen between 0 and 2 seconds. So our domain is going to be written like this. The time is greater than or equal to 0, and the time is less than or equal to 2 seconds. Normally we would write all real numbers, but since this is a word problem that starts at 0 seconds and ends at 2 seconds, that is our domain for this problem. All right, so for the distance, normally we would say y is less than or equal to 64, but on this problem, it doesn't keep going down forever. So the rock lands, stops, hits the ground at 0 on the y-axis. It would look like this. I would say our distance is greater than or equal to 0, and our distance is less than or equal to 64. So on a word problem, sometimes your domain and range are different than what you're used to when you're doing a problem that's just a graph with no context or no real life application. So that's how you would do this problem. It's really a factoring problem more than a graphing problem. On this problem, they're asking us to figure out what happens when x is less than 5. Well, on the x-axis, here's 5 right here. So when x is less than 5, they're talking about this side of the graph right here. Everything to the left of the vertex. And it says when x is less than 5, y increases as x does something. So we got to look at our y's right here. Here I have a y of 1. Here I have a y of 3. Here I have a y of 9. So my y values are increasing, just like it says. Well, what's happening to my x's while the y's are increasing? My x's go from 5 to 4 to 3. So as my y's are increasing, my x's at the same time are decreasing. So what we should put in the blank right here is y increases as x decreases. Now, the second part of the problem, they're asking us what's going on when x is greater than 5. Well, when x is greater than 5, they're talking about the right-hand side of the parabola. And it says the y's increase as x does something. So let's look at the y's again. I have y equals 1. I have y equals 3. I have y equals 9. So while the y's are increasing, what's happening to the x's? Well, the x's are going from 5 to 6 to 7. So as the y's are increasing, the x's are also increasing. So the answer to the question, when x is greater than 5, y increases as x increases. This problem is basically the same as the last problem, except on this problem, the parabola opens down, which might change our answer. So the first thing they want to know, when x is less than negative 4. Well, when x is less than negative 4, they're talking about the left-hand side of the graph. That's where it's less than negative 4. And it says y increases. Y increases. Well, for y to increase, we're going to have to take a look at this. This is negative 7. And bigger than negative 7 is negative 1. And bigger than negative 1 is positive 1. So the y's increase as we're going up on the graph. Well, as the y's increase, what's happening to the x's? The x's go from negative 8, and bigger than negative 8 is negative 6, and bigger than negative 6 is negative 4. So as the y's increase, the x's also increase. So the answer on this problem, when x is less than negative 4, y increases as x increases. Now, what about the other part of the problem? When x is greater than negative 4. Well, x is greater than negative 4. That's the right-hand side of the parabola. And they're saying y increases as x. So we got to figure out the y's increasing. Well, the y's increase by going from negative 7, and bigger than that is negative 1, and bigger than that is positive 1. So the y's are increasing as we go up. What's happening to the x's? Well, the x's are going from 0 to negative 2 to negative 4. So the x's are getting smaller. So y increases as x decreases. And our final problem, the function y equals negative 16t squared plus 40t plus 3 describes the height in feet of a soccer ball t seconds after it is kicked. Find the maximum height of the ball. Well, I'm going to give you a hint, and then I'm going to ask you some questions at the end of the video after you figure out the problem. So we know on this problem that our a value is negative 16. So it's going to open down, and it's going to have a vertical stretch. We know that our y-intercept is 3. We know that our vertex could possibly be a decimal. We're going to have to calculate it, but don't worry about that because this is a real life problem and things happen in tenths of a second or hundredths of a second. So you're going to find your vertex by using negative b over 2a and y equals ax squared plus bx plus c. Then you're going to find your axis of symmetry and your range and your domain. But really, to answer the question, you just need to find the maximum height. You can find that by knowing your vertex. This is going to be a parabola that opens down, so it's going to look like a rainbow. And your vertex is going to be on the very top of that rainbow-shaped parabola. So if you know the y-coordinate of the vertex, you know the highest point on the parabola, which in this problem is the highest or maximum height of the soccer ball.